Okay, so this is the beginning of the review for test 3. All right, this obviously doesn't have circles or endpoints, so those have arrows. Does a parabola open up or upward or downward? Obviously, it opens downward. Find the equation of the axis of symmetry. Remember, the axis of symmetry is this invisible line that goes down the middle of this. It's not a very good line, but pretend like it is. And it is at 2. I'm going to fix that because that bothers me. Okay, so I'm going to get out my credit card. I know you guys probably don't care, but so it's this imaginary line that goes down like that. Okay, so that happens at 2. It is an equation, so it needs to be x equals 2. You can't just put 2. It has to be an equation of a line. Now, find the coordinates of the vertex. The vertex is right here. It's rather the highest point or the lowest point, and that occurs at 2 up 1. So it's 2, 1. See if I can fit that in there. Okay, the x-intercepts, where it crosses the x-axis, that crosses at 1 and at 3. So again, I'm not sure 1, 3, or remember, they are points. It is 1, 0, 0, and it is 3, 0. Just know that it's an ordered pair. There can be no x-intercepts. There could be 1, 2, 3. It depends on what it looks like, okay? Don't think that there's always 2 or there's always 1 or there's always, none or multiple ones, okay? But I will tell you this, there is only one y-intercept for every one that we're going to deal with, and it's right here, and that is at -3. If you were to put the ordered pair, it would be 0, -3. The x-intercepts, the numbers are in the x position. The y-intercept is in the y position. Make sure you do that correctly. Okay, number 2. Okay, we got a quadratic. Quadratic just means it's x squares. Okay, does the function have a minimum or maximum value? Well, you have to look at a. A is what's in front of the x squared, so it's -3. If it is negative, the parabola opens downward. Negative people bring you down. So now that you're looking at what it looks like, you can tell that it has a maximum. What is the function? Sorry, I keep moving this because it's not, I need to move my document camera instead of the paper. What is the function's minimum or maximum value? Anytime you see those words, you need to think vertex, okay? To find the x value of this vertex, you are going to say x equals -b over 2a. You get that answer, and then you plug it back in to get your y answer. Okay, so in this case, our x value, it's -b, so it's 24, so it's going to become a -24 over 2 times our a, which is -3. So you get -24 over -6, and that gives us 4. So it says, what is the function's minimum and maximum value, and where does the minimum or maximum value occur? That is our x value, so that 4 goes here. This is asking for the y value, okay? This is the y value. So in order to find that, you take this 4 and you plug it in right here. You would say 3 or -3 times 4 squared plus 24 times 4 minus 46. And I do not think I have my calculator handy. I wasn't prepared to do a video apparently, so I'm just going to use my phone. So we get negative 48 right here, plus 24 times 4 minus 46, and I get 2. Okay, so that is our value where it occurs, and this is at x equals 4. That means it is the point 2, 4. Okay, so I'm just going to double check my calculations there, because I may have plugged something in wrong, just because I'm using my phone. Minus 46, and I did. This is wrong right here. Okay, hold on. So that's 16, negative 48. I don't think I put negative. Plus 24 times 4 minus 46. I came up with 2. Hold on. I got to change over to my scientific calculator. I'm trying to do it on the regular. All right, so negative 3 times, I'm just going to put in 16. Oh, it's got a bad glare, doesn't it, on my phone? Okay. That gives us the negative 48 plus 24 times 4 minus 46. It does give me 2. If I plug in 2 into, oh, I'm sorry, that's what I did. I checked my answer. I plugged in 4 and I should get 2, but I was doing it the other way. So hold on just a second. I was plugging in a 2 instead of that. So anyway. And that will do. Sorry, I just screwed that problem up, but it's right. Okay, let's take a look down here. A ball is thrown vertically upward after t seconds. Its height, h in feet, is given by the function of this. How long will it reach its maximum height? Okay, so this here is our height. Okay, and this, our t, is seconds. And it asks for how long. So we are trying to find what t is. Okay? No, we're not. It says how long will it reach its maximum height? Oh, duh. I'm not doing too well. Okay, it's just like being in class. Maximum, think vertex. Okay, so we're going to say x equals negative b over 2a. In this case, x is t. So we're going to say t equals negative b. B is what's in front of our t, not our t squared. Just because these are switched, b is always what's in front of your t. So it's going to be 56 over 2 times our a. Our a is always what's in front of our x squared or t squared in this case, which is negative 16. So we have negative 56 over negative 32. So when you do that, that gives us a positive 1.75. I'm going to double check that. 56 divided by 32, because I'm using my phone for my calculator. Okay, t stood for seconds. It says, how long will it reach the maximum height? So that's our answer. If it had asked us what the height was, you would take this and plug it in here and find out what that maximum height would be. But it didn't ask for that, so we don't have to worry about it. Okay, so when we were finding the vertex and how long was our x value, how high was our y value. All right, graph the quadratic function with the vertex of negative 2, negative 4. Or use the graph, I guess, is shown in the figure below. Find the domain and the range. Remember, domain is our x value. I will have to say this, you have to be careful in ALEKS. Sometimes it will put the range first. Make sure you are doing this correctly. Sometimes they'll switch this, but today, this problem, it's good. All right, you don't see any holes in this graph. They are using all x values. And you have to do it in interval notation. This one would be negative infinity to infinity. The range, however, goes from lowest to highest. The lowest is -4. And because there's no hole right here, it's going to be a solid circle. And it goes this direction all the way up to a positive infinity. So the range would be bracket, because it's included, -4 to infinity. Number 6, find the range of the quadratic function. Well, the easiest way for this is to actually graph it, okay? But I don't have my graphing calculator, so what will I do? Well, the first thing I'm going to do is find that's a bad graph. I'm going to find my vertex first of all, okay? I don't know if this one will be any better, but hopefully it will be. The vertex, I'm going to say x equals -b over 2a. So it's going to be -6 over 2 times 1, which gives us -6 over 2, which is -3. Okay, so now that we have that, we're going to find our y by plugging it in. We're going to say -3 squared plus 6 times -3 plus 7. 9, this gives us 18, which is -9 plus 7, that gives us -2. So this is the point, -3, 2. Just going to double check to make sure I did it correctly, because you got to watch me. Yeah. Okay. Well, this should be a -2. All right, so I'm going to go over to -3. 1, 2, 3. And I'm going to go down to -2 and put my point. Okay? Now, I know it's going to open up because my A is a +1 and positive people bring you up. So I'm just going to do a rough sketch of this. Okay? Now that I know that, it's only asking me for the range. The domain of quadratics, it's always all real numbers, because the only thing you can't do is you can't divide by 0, and you can't take a square root of a negative number. Seeing we're not dividing, we can't divide by 0, so I don't have to worry about that, and there's no square roots. So the domain would be all real numbers. Now the range, however, seeing it's only asking for that, the lowest point is right here at -2, and it goes up like that. There is a point at -2, so the range is -2 to a positive infinity. And that's the answer to 6. Okay. Again, it only asks for the range. If it had added the domain, it would be -infinity to positive infinity. These are so big. Okay. For this question right here, you have to remember a formula. In vertex, it's the formula, I don't know if it's f of x, or I guess it's a function g, so we should call it g of x. This one's kind of a weird one to try. If you're going to struggle with any of them, I'd say this is going to be one of them. First of all, you have to remember the formula. So it's a times the quantity of x minus h plus k, where h and k are our vertex. Now, when I grade these tests, and again, don't forget this is the same as y, okay? When I grade tests and I see the common mistake I see is they use this for the vertex. The vertex is the lowest point. So right now, I'm going to put y right here. I have a because I don't know what my a is, but I do know it's x minus my h, which is this, because this is hk, minus 4. And because this is a negative 5, it's going to be minus 5. You can put plus a negative 5. That would be fine. Now, the problem here is we need to find out what a is. To find that out, that's where this point comes into play. This is we're going to substitute x comma y right there. So I am going to put 3 in for y, and I'm going to put 6 where I see x. And so this is what I'm going to have. Now the only variable that I have left is a. So I have 3 equals, inside here that gives me 2. So I have a times 2, so I'm just going to say, write that as 2a minus 5. I'm going to add 5 to both sides, because I'm taking the 5 over here. I get 8 equals 2a, divide by 2, and a equals 4. Okay, now that I have my vertex and I have a, I can write my function. Using this right here, I'm going to put g of x. The reason I'm calling it g of x is because it says a function g equals my a, which is 4, times x minus, oh, and I worked this one wrong. I forgot my square right here. It's just going to change a little bit, okay? It's going to be right here, okay? This gives me 2, squared gives me 4. At least I caught it. Sorry about that. That becomes a 4, so now I'm going to divide by 4. And my answer for a is 2. All right, let's try this again, running the function. Okay, my a is 2. So now I'm going to have x minus, I'm going right back to this formula right here. I'm just plugging 2 in there. 4 squared minus 5. And there's the function. And you should be able to plug this into your calculator, and this and that point there should be on this graph. Okay? All right. Find all the zeros of the quadratic function. All you're going to have to do, remember, a 0 is the same thing as an x-intercept. There could be 1, there could be none, there could be 1, there could be 2, but there's no more than 2 because you can't have any more zeros in your highest than your degree. What you're going to do, all you do is factor this. It's going to factor as x minus 9 times x minus 9. And you set this equal to 0. Because remember, x-intercepts and zeros are the same thing. And x-intercepts, their y values are 0. Here, my x is going to be negative 9. I'm sorry, it's going to be a positive 9. Same thing here. So we only have 1 0, which is 9. All right, for each function, determine whether it's a polynomial function. Polynomial functions have only positive exponents. Other things is there's no square roots, there's no fractional exponents, and you're not dividing by 0. Okay. Here, the only thing we have all positive exponents. That's good. Okay. We're not dividing by 0, so that's fine. There's no square roots, so yes, it's a polynomial function. Right here, yes, we're not breaking any rules, basically. Here, we have a square root. That means it's the same thing as x to the 1/2. Well, you can't have that. You got to have whole numbers. So this one would be no. And this one would be yes. If you had something that looked like this, f of x is equal to, let's say 2x plus 3 over, let's say 5x, where you have an x in the denominator, this would not be, it would not be polynomial, okay? It's a function, it's just not a polynomial. So this would be no. Something like this, 5 over 3x plus 1, no. But if it was something like this, 7x plus 8 over 10, then that would be a yes. That is a polynomial function, okay? Because again, it has to do with x being in the denominator. All right, find all the zeros. If you see it like this, you should be happy, okay? Because it's already factored for you. You don't have to do anything with it except for find out what's going to give you 0 here, 0 here. Let's try and show you. There we go. All right, this has an x out there, so you have to worry about it. In this particular case, it would be 0. Now, how did I get that? Just like I would here, and just like I would here, I would get 2x, negative 2x equals 0. I just set it equal to 0. And I get x is equal to 0. Same thing here. You get x squared minus 16 equals 0. Now, there's two ways you can do this square root property, or you can factor x plus 4, x minus 4 equals 0. Where here, your x is equal to a negative 4. Here, it's equal to a positive 4. Now, on this one here, nothing will give you 0. Not real answers anyway, right? We don't deal with imaginary numbers. Okay? This will not factor. The only way it will factor is if this was a minus sign. So this doesn't have any zeros. Some of you are going to say, well, what about 7? 7 squared gives us 49. 49 plus 49 gives us 98. Some of you may say negative 7. Negative 7 squared gives us a positive 49. Plus 49 gives us 98. So nothing here. Some of you are going to say, well, let's use the square root property. Well, if you take that over there, you get negative 49. Remember, in our class, we can't do this. We can't take square root of a negative number. So we don't have to worry about that. So our zeros are 0, negative 4, and 4. And I really technically should put that in order. Negative 4, 0, and 4, but I don't really care. Okay, and that was all on that one. This one says it's a function. List each 0 and of f according to its multiplicity in the categories below. Okay, so here's what I'm going to do. I like to just do it like this. My 0 here is negative 2. My 0 here is negative 5. And my 0 here would be 9. Multiplicities come from your exponent. This one doesn't have an exponent, but it really does. It's a 1. We just don't write it. Same thing here. So my negative 2 comes from this, so it's a multiplicity of 1. Right here, negative 5 comes from this one. It's a multiplicity of 1. And right here, it's a 9 comes from here. Its multiplicity is 3. Now, why do we need to know this? If these are odd, if they have an odd multiplicity, they cross the x-axis. If they have an even, they touch it and bounce back. All right, choose the end behaviors of the graph for each polynomial function. All right, so right here, first of all, everything comes from the first, or I guess the degree. Okay, so what we're going to deal with in this one is 3x to the third, the one with the highest degree, the highest exponent. The degree is 3, so it's odd. Okay, again, the degree is 3. Not that we have to have the 3, but the degree comes from here. So it is odd. That means they go different directions. So you go to your leading coefficient, which is 3, which is positive. Has a positive leading coefficient. So that means, this means they go different directions. Okay? They rather go like this, down on the left, up on the right, or this. That's where your leading coefficient comes into play. If it's positive, looking at, it's always going to be up on the right. So it's this one right here. So now, they like to do it here, okay? So I'm looking at how they have this written. It falls to the left and rises. Oh, okay. Okay, so you have to pick between here. Okay, it's confusing me. It falls to the left, so this one, and it rises on the right, so it's this one. Okay, this one here, we're dealing with the one with the highest exponent, which is 3x to the 6. Has a degree of 6, which means that's an even. That means they go the same direction. They rather both go up or they both go down. One of the two. So you go to your leading coefficient. It's a positive 3. I don't care that it's 3, just that it's positive or negative. Positive people bring you up. So it is this one right here. You can look at the one on the right. That would always tell you. So it rises to the left and it rises to the right. Now this last one's a little bit harder because they don't give it to you in this type of form, in standard form. They give it to you in factored form. Well, remember, this is negative 3x times an x times this would be an x squared. You can multiply it all out, but this is just wasting your time when you can just do negative 3x times an x squared. That gives you negative 3x to the 4th. They like 3 in this problem for those leading coefficients. Okay, so in this particular case, you have a degree of 4. That is even. Again, they're going to go the same direction, the ending behaviors. Okay. That means they're rather both going to go up or they're both going to go down. So now you have to go to your leading coefficient. Your leading coefficient is negative 3. Again, I started to put a negative 3. We don't necessarily care whether it's the 3, 4, or whatever. It's just that this is negative. Negative people bring you down. Look at the right-hand arrow. It's this one here. So that's that. It falls to the left and it falls to the right. And that's it for this video.